Hello everyone. So now we are going to start with our next topic in the vector, one more operation, that is subtraction of vectors. Okay. So how we subtract two vectors and we are going to find out the magnitude of the resultant of those vectors. So let's say we have two vectors here. What are those? We have our one vector is like this A vector and we have B vector. Okay. And the angle between them is theta. Okay. This is given. Now I want to find out, so angle between A vector and B vector is theta, right? This is given. I want to find out C vector, okay, magnitude, that is A vector minus B vector. Okay. So how to find out that? So can I write C vector as A vector and plus minus B vector? So it's just an addition of two vectors, which is A vector and minus B vector, right? Okay. So how to find out minus B? We have seen if you multiply with a minus 1, that constant value, then magnitude is going to be same, then direction is going to change. So direction is going to be this. So A vector and B vector angle is theta. So this is how much? 180 minus theta, right? This we have already seen. Okay. So just you apply the formula in magnitude of C vector, okay, that is C is equals to under root of A square plus B square, right? Minus B, magnitude is B only, right? Plus 2AB cos of angle between A vector and minus B vector, that is 180 minus theta. Now cos of 180 minus theta, we know 180 minus theta means second quadrant. So second quadrant means angle is cos is negative, right? And it will not change to complementary. So C equals to under root of A square plus B square minus 2AB cos theta, right? This will come your, if you want to find out C is A vector minus B vector, then magnitude of C vector is equals to under root of A square plus B square minus 2AB cos theta. Okay, this you have to remember. I will write it down again here. Theta equal to angle between A vector and B vector, not between the A vector and minus B vector. It is between A vector and B vector. Okay. Now next thing which we are going to see is, if A equal to, now let's solve some questions. If A equal to 3 and B equal to 2, if C equal to A minus B, then magnitude of C. Okay. That's simple formula based question. C is equals to under root of A square plus B square minus 2AB cos theta, right? Minus 2AB cos theta. So you put the values, 3 square plus 2 square minus 2 into 3 into 2 into cos of 60 degree. Cos 60, you can put the values, right? So from here if you solve, you're gonna get C equals to root 7. C gonna root 7, magnitude of the C. Okay. Next question is, if A minus B vector plus C vector and A equal to B, magnitude of A equal to magnitude of B equal to magnitude of C, then find angle between A vector and B vector, B vector and C vector, and C vector, A vector and C vector. This kind of very important question, good question. How to solve this question? First of all, here I can say directly, if I want to answer, A vector plus C vector is equals to B vector and magnitude are equal, right? So I can apply a triangular law. Okay, here A plus C, so means let's say this is your A and this is your C, which is coming equal to B. So this is your B this side. Okay, so and magnitudes are equal, so this all angles gonna be 60 degree. Okay, 60 degree, 60 degree and 60 degree. So I can say angle between A vector and B vector, A vector and B vector, tail and tail are connected, so angle between A and B vector will be 60 degree. Okay, then B and C, if I want to answer B and C, so head to head connected, so I can answer this angle. This is also 60 degree. And A and C, okay, head to tail connected, so I have to shift this A vector, so this is gonna become 120, so this I can answer 120 degree. Okay, this is simple. Okay, second method is how to solve. You take, I will answer this one for one. Okay, let's you take you take 1 on the other hand side and put the magnitude. So you take whatever you want to take, a vector plus c vector equal to b vector, okay, and you put the magnitude now. So what you can say, under root of a square plus b square plus 2ab cos of angle between a and c, so theta ac I can say, is equals to b, right? Now I know the magnitudes are equal, so I can put any value, a square plus 2a square cos of theta ac equal to a square I can say, okay. So from here you will check cos theta of ac, okay. So if you check this will gonna come minus 1 by 2, okay. So by that I can say theta AC equals to 120 degree. So this is how you solve. Now if you want to solve for the A and B, then you take C that side and B this side. So A minus B is equals to minus C. If you take magnitude, A square plus B square, okay, sorry, here it gonna come C, right? Same thing is gonna happen. So AC, yeah, correct now. Okay, like this. I hope this is clear. This is how you calculate. Now you want to calculate A angle between A and B. You take C that side and B this side, and then you take magnitude both sides. Okay, simple. Next thing is, next question. If A and B, A minus B का mod is equals to A plus B का mod, and A and B have non-zero magnitude, then find angle between A and B. Okay, fine. So angle between A and B, let's assume that is theta. So how do we write? Under root a square plus b square minus 2ab cos theta, okay, is equals to under root of a square plus b square plus 2ab cos theta. So if you square them, a square b square cancel out, okay, this is gonna come in one hand side, a and b are non-zero, so you're gonna get ab cos theta equal to 0, okay. So now here a and b are non-zero, it already said, okay. So cos theta have to be 0, okay. So if cos theta 0, theta equal to 90 degree, right? So angle between A and B is 90 degree. That's how we answer, okay. Now let's go for next thing. Next we have unit vector, okay. So what is a unit vector? Little bit we have already defined, okay, but still let's define this thing, okay. So what we say about unit vector? Unit vector is a vector which have a magnitude equal to 1, okay. Now how to say? We can write this thing, right? Any vector is multiplication of its magnitude and its unit vector, right? So here A is the magnitude of A vector and A cap is the unit vector or direction of A vector, right? Now if you divide this magnitude in this side, then you're gonna get A cap, okay. So simple. If you want to calculate a unit vector of any vector, okay, then you divide that vector with its magnitude and you're gonna get the unit vector, okay. Simple. We're gonna see later on questions on basis of that, okay. For now this is the how we define unit vector. Now let's go for the coordinate system and convention. So how you define the coordinate system, 3D coordinate system, okay. This is very important, okay. This is your x-axis this side and your y-axis above and your z-axis coming out of the plane, okay. Z-axis out of the plane, okay. Now how you define? Along the x-axis you define a unit vector that you call as I cap, okay. Along y-axis you define j cap and along z-axis you define k cap, okay. So if this is I cap, so 180 degree turn you take, then it is minus I cap. Unit vector along minus x-axis is minus I cap. This is minus j cap and this is minus k cap. I hope this understood. What we took? We took a unit vector along x-axis, we call it I cap, okay. So its magnitude is 1, okay. And along y-axis we take one unit vector that is we call as j cap, and along z-axis unit vector we take that we call as k cap, okay. So let me write this. I cap is equals to unit vector along x-axis, j cap equal to unit vector along y-axis, and k cap equal to unit vector along z-axis, okay. I hope this is clear. Now I'm defining two more things, okay, that is circle and this dot. What this is, okay, if a vector is pointing out, you understand it's like this, then one thing is like this, circle and cross, okay. What is these two things? You understand this thing, you understand it by like an arrow, okay. So if you see arrow from the front, okay, if arrow is coming towards you, what you see? You see a circle and a dot, right? Okay, so this thing is, if vector is coming out of the plane, okay, coming out of plane or paper, we can say, okay, this paper, okay, and this is going inside the paper, okay, basic thing, okay. This is back side of the arrow, right? You have a like this, so this is your back side of the arrow, so this is going inside the paper and this is coming out of the paper, okay. I hope this is understood, okay. This we will gonna use, okay. Now next thing we have is resolution of vector in component form. So how to resolve any vector in its component, okay, along x-axis and y-axis. Now any component we can resolve, but mainly we'll discuss along x, y and z axis, okay. So now we have an a vector and we want to resolve it along x, okay, and we're gonna resolve this side with y like this, okay, and resolve, okay. So I can say here magnitude of a vector is equals to a, okay. So from this triangle I can say, if I assume that this angle is theta, okay, it is making with x-axis is theta, so what can I write from here? Sin theta. Sin theta is my y by a, right, and cos theta is my x by a, right. So from here y is equals to a sin theta and x is equals to a cos theta. This I can write, right. Now what can I say from here? Now in this triangle, if you see like this and like this, okay, so I can say this vector is along x-axis, right, and what is the magnitude of this? A sin theta, right, okay. So I can write a vector from triangular law of addition. I can write a vector is equals to this vector plus this vector, right, and this vector is along y-axis and this vector is along x-axis. So magnitude is a sin theta and this magnitude is a cos theta, right. So what can I write? A sin theta, sorry, magnitude is a cos theta, this is x, okay, x is a cos theta, a cos theta. What is the direction? I cap, right. I can write in terms of unit vector, right, okay. And similarly a sin theta, in y direction magnitude is this and direction is j cap, so that is j cap, okay. That's how it came. So this is your x component of your vector and this is your y component of vector, okay. Now how to do this thing? Okay, whatever magnitude is given, you drop a perpendicular here, okay, and then you take the component along x and along y, and this is how you can write a cos theta. So this along x-axis I can say a cos theta component and along y-axis I can say a sin theta component, right. So that's how. So I can write any vector in this form, okay. I hope this is clear, okay. It's simple. Magnitude into its direction. So magnitude is x, that is a cos theta, and direction is I cap, right. And here magnitude is y, that is a sin theta, and direction is j cap, right. I can shift, parallelly shift, okay. So this is j cap. So any vector I can write in terms of a cos theta in sin theta, okay. I hope this is clear, okay. Now one more thing you have to understand this thing, better you understand now only, so later on you don't have to struggle, okay. Whatever axis it is making angle with, okay, if you take along that axis, that is gonna come cos theta, okay, okay, and the perpendicular axis is going to come sine theta component. Okay, let's take an example. We will solve later on examples. Okay, so here with along that direction of theta is going to come cos theta component, a cos theta, and perpendicular axis is going to come with which it is not making angle is going to come sine theta. Okay, now let's solve some examples here. Okay, let me complete the question for you. Okay, we have given this a vector with a magnitude of 5 and this angle is given 37 degree, right? So how we will write the a vector in terms of I cap and j cap, how to write down? Okay, I have told you along x axis you will take cos theta component. Okay, along with its making angle, so I am going to take 5 cos 37 is my I cap plus 5 sin 37 perpendicular axis, like this you can draw. Okay, this is your cos theta component, this is your sin theta component. So 5 sin 37 j cap. Okay, so what it's going to be, a cos 37 is you can put, and that is 3 I cap, this is going to be 4 j cap. So this is your a vector. Okay, now let's go for the next question. Okay, what is given here, this angle is given 53 degree. Okay, and this magnitude of a vector is given 10. Then how to write? Now see here, along this and along this, I have told you with which it's making angle. Okay, that component is cos theta and the other component is sin theta, right? So here if you write a vector, okay, very precisely you have to write what it is. This is a cos theta, right? So a sin theta this side, x axis. So a, that is 10 into sin theta, sin 53, sin 53. Now I cap, but it is negative direction, so minus I cap. Okay, it is on minus I cap direction, so minus I cap, plus this is gonna come 10 cos 53 and plus j cap direction, so directly I can write j cap. So a vector is equals to, how much it came? Here came this minus 8 I cap plus 6 j cap. Okay, this is your answer. Now let's go for the next question. What we have this side with the angle, this angle is 60 degree and magnitude is 20. Okay, now how to answer this? Okay, simple, you draw a here perpendicular. Okay, so I can write a vector is equals to first 20. Now in x direction it is sin 60, right? This with which it's making angle, that is cos, and other one is sin. So a sin theta, so that is sin 60. Now it is minus I cap direction, so minus I cap. Okay, plus 20 cos 60, right? And this is minus j cap direction, right? This is minus j cap. Okay, so I can write a vector is equals to minus 10 root 3 I cap minus 10 j cap. Okay, this is your answer. Okay, I hope this is clear. Now next question is little bit more tricky. Okay, so what is happening here is this vector is like this. Okay, so better you solve like this only. Okay, the angle is given here, this is 30 degree, this angle is given 30 degree. Okay, so what can I write? A vector magnitude is given 10. Okay, now let's solve this question. How to solve this? A vector is equals to I cap. What can I write in I cap? I cap, it is this side. See, this component is going to come this side, one component, and this side other component. That's how. So I cap, it is going positive direction. Okay, so what can I write here? 10 cos 30 in I cap direction. Okay, plus 10 sin 30, that is going to come minus j cap. Okay, so this a vector came 5 root 3 I cap minus 5 j cap. Okay, I hope this is clear. Okay, Now let's read the note. What note says is, if you have a ax I cap plus ay j cap, so I can say this is a vector and your this component is ax and this component is ay, okay, and this angle is alpha, okay, and this angle is beta. So I can say alpha is the angle between its one component and a vector, and beta is the angle between the its one component and a vector, okay. So what is the angle a is making with the x-axis? So angle with x-axis, that is alpha, right? So what can I write about tan alpha? Tan alpha I can write ay by ax, right? Ay by ax, so that is right from here this triangle tan alpha. So y component divided by x component, okay, and angle with y axis I can write angle with y axis tan beta, okay. Tan beta you can write, you can shift this ax here, right, and ay here. So tan beta will be perpendicular upon base, that is ax upon ay, right? Ax upon ay. What is ax? X component divided by y component, okay, that's how. So you don't have to remember this, you can draw this anytime. If the with the x-axis it is arched angle, okay, you can remember if you want, but I don't recommend it to remember, okay. You don't have to remember every single formula, just you remember the concept how to get this, okay, that's all. That is the main thing, okay. Now let's see next question. A vector equal to 3 I cap plus 4 j cap, then find magnitude of A. So magnitude of A, how will we find out? It's written in terms of x and y. So I know I cap and j cap are perpendicular to each other, right? Sum of two vectors. So basically magnitude of A vector is equals to under root of 3 square plus 4 square and 2ab cos theta, that gone 0, right? So let's write down that also here also. So also I can say magnitude of A vector is equals to under root of ax square plus ay square. This you can remember, okay. So here I can write, apply that formula in this came 5, okay. Next thing, angle with x-axis and y-axis respectively. So just you draw this, not a problem. What is this? Like this, okay. With x-axis this is 3, this is 4, okay. This length is 4 and this length is 3. So he is asking angle with x-axis alpha. So I can write from here tan alpha equals to 4 by 3. That means alpha is equals to 53, right? Alpha is equals to 53. And so beta automatically, this beta automatically it got 37, right? Your total is 90, right? Next question, magnitude of A vector is 8 and its x component is root 3 times of y component, means x component, that is ax, is root 3 times of ay. That's how, okay. And so magnitude I can write a square equals to, square you both sides, a square equals to ax square plus ay square, okay. What you want, write A vector in component form, angle with x-axis and y-axis, okay. So from here 8 square is equals to ax square plus ay, I can, let's put ax value, okay. So ax is root 3ay, so 3ay square plus ay square, okay. So ay from here it came, from here I can say ay equals to how much, 3 4 64 by 4. So okay, and then you take under root, so basically 8 to 4, okay, it's gonna come 4, okay. And ax is equals to root 3 4 root 3, right? That's how, okay. So I can say your A vector is basically 4 root 3 I cap plus 4 j cap. Okay. The angle with x-axis, y-axis that you can answer, tan alpha is your y by x, right? So that is 4 by 4 root 3, that is 1 by root 3. So tan alpha is equals to 1 by root 3, that is 30 degree, right? So beta is equals to 60 degree. I hope this is clear. Next question we can see, that is my A vector having magnitude 10 has x component 5, then y component equal to. Simple, 10 square is equals to 5 square plus ay square, right? So ay square equals to 100 minus 25, that is 75. So ay is equals to magnitude, I can answer root 75, right? Root 75 is 5 root 5. Sorry, 5 root 3. Okay, 5 root 3. So y component he asked, then angle with x-axis and y-axis he asked. So basically he asked the tan alpha. So tan alpha is equals to 5 root 3 by 5. So that is root 3. So alpha is 60 degree and beta is 30 degree automatically, because alpha plus beta is 90. Okay. I hope this is clear. Now next question. A vector makes angle 37 degree with x-axis and y component is 6. Then find x component and whatever. So let's go with the diagram. As I told you, don't have to remember the formula. Okay. What is saying that having y component 6. So it's like this. You have a vector here, okay, which having the magnitude y component 6. So this is 6 and this angle is making 37 degree. Okay, so its magnitude, let's say x. Okay, so I can say tan 37 is equals to 6 by x. Okay, so x is equals to 6 by tan 37. So you can write the value of tan 37, and you got the x equals to 8. Okay, so what can I write about x component, right? X component, right? So ax came 8. I got one thing, first part. Second part, what he is asking, magnitude of a vector means under root of ax square plus ay square, that is under root of 8 square plus 6 square is asking. That is my 10, right? So my magnitude is 10. I hope this is clear. Okay. Thank you.